All right. So there are many intelligence tests on the market today. One of the things that they have in common is that they are what we call standardized. I'm going to go back to my previous slide for a second, because standardized tests are, for one thing, they've been normed, right? So we have a bunch of people who have taken the test, and we know what an individual's raw score, where it's going to fall on the norm distribution. And so that's one factor in standardization. Another aspect of standardization is that the way that the test is administered is standardized across all test takers. It's not even like taking SAT, if you've ever sat for that, where you're in a big room and you're supposed to have turned everything in and all you have is a pencil. And it's like, that's kind of standardized, but it's kind of not, in the sense that you are left to your own devices to read those questions, to interpret them as you see fit. You can't ask anyone any questions about the questions. You just have to take the test. That's not how standardized intelligence tests are administered. So if you've ever taken an intelligence test on the internet and gotten whatever score you got, if you were happy with the score, oh, I'm sure it was a perfect test, so just let it go. I don't ask any more questions. But if you were unhappy with the score that you got, please remember that you didn't take a standardized intelligence test. You took a test on the internet. It doesn't mean anything. Standardized tests are rigorously administered. And in fact, you have to be qualified to administer one of these tests. You have to be trained in the protocols. So I'm going to give you some sample items. Some of them are from the WACE, some of them from the WISC. All of them are from Wechsler. The W in this term stands for Wechsler. That's the name of the person who first invented it. The A is for adult, the I is for intelligence, and the S is for scale. So this is the Wechsler Adult Intelligence Scale. Some of the items I pulled actually are from the WISC, which is the Wechsler Intelligence Scale for Children, because it was easier to find those. So both, whether you're taking the WISC or you're taking the WACE, it doesn't matter. They both are divided into a verbal portion. So now these are some examples from the adult side. You have the category of vocabulary. For adults, you might be asked, what is a lute, right? In case you're saying to yourself, I don't know, it's an stringed instrument. But you'd be asked that question, and then you're supposed to answer it actually aloud. You don't have to write it down. It's not a multiple choice question. The test administrator asks you the question, and you answer the question. Comprehension, for example, what does it mean to say, don't judge a book by its cover? So the test administrator asks that, you answer it, and if you give an incomplete answer, they are trained in how to give you like a follow-up question to help make sure that you realize you're given the opportunity to answer it as fully as you possibly can. Similarities, for example, in what ways are an airplane and a car alike? Information, who is the president of Russia? So these kinds of verbal questions, they're delivered verbally and you respond verbally, and it's all oral. Performance, some people call this the nonverbal component, although the instructions are still verbal, so it's a little bit of a misnomer. On the performance side, you have things like picture completion, right? So you see the prompt at the top. This is where I think all of the performance ones are actually from the children's test. But so you see the prompts at the top, and then you're supposed to figure out which of the options at the bottom would complete that picture, right? Picture arrangement. So you're given this series of pictures, and the pictures are numbered for what order they should be placed into to tell a story. So yeah, I think that's right. 1, 2, 3, 4. Yeah, I don't know. Picture arrangement. So you're supposed to tell a story with the pictures. Block design, you are provided with three-dimensional blocks that have, one side solid red, one side's solid white. There's like the diagonally half red, half white. There's the horizontally half red. So they're three-dimensional and you can rotate them. And then you're shown a picture like this on the left where you're supposed to make a diamond out of it. And using your three-dimensional blocks, you're supposed to, on the top of those blocks, once you've put them all together, looking down on them, they should look like the picture. Object assembly, this is again from the WISC, so this is a kid one. You'd be given basically a puzzle, but it's a weird puzzle. It's not the kind that, you put all the edges in first or something. It's a puzzle where you don't necessarily, you don't get to look at the box and see what the picture's going to be. You have to just put it together and make it into something. So they call that object assembly. And then there's digit symbol substitution, where you're given this key at the top where you see that 1 is a horizontal line, 2 is an upside down T, 3 is sideways C, so on. And so now you're given the just the numbers, and you're supposed to put the code in under the correct number. So it's looking back and forth. It's a little bit of a working memory capacity kind of test to do this digit symbol substitution. It requires working memory. So these are the subtests, right? And you can see why they might call the performance one, that's the non-verbal ones. I just like to point out that it's non-verbal in the sense of what you're doing doesn't require a verbal response, but the instructions are still verbal. So you would still need to speak the same language as the test administrator, things like that. So those are the subtests of the WACE, the verbal and the performance side. Here's a different test called Raven's Progressive Matrices. And this one's kind of like the performance side of the WACE, or the Wechsler in general. Here you have, it's called progressive because you're supposed to start here, the square, then it's a diamond, then we have a square with a cross on it, and then this blank needs to be filled with one of these 6 options at the bottom. And so you're supposed to figure out what is progressing that would make it make sense to fill in this bottom one, right? So you've got an empty square. Actually, if you go down below, you see a square with a plus sign on it. You have an empty diamond. So more than likely, the correct answer should be the diamond with a plus sign on it, right? And they get way more complicated. So as you go on, this actually might be from the children's test also. As you go on, there's like 16 things there, and you're supposed to be paying attention to the relationships among all of them and fill it in. This one is considered a nonverbal test because you don't need to be able to speak any particular language in order to correctly answer these questions. So those are examples of the tests. Now, one of the things that we have to consider with regard to using tests to measure a construct like intelligence, intelligence is like, we all kind of know what a person means by that word, but it's not a concrete thing. And what we're trying to do is take that abstract concept of intelligence and convert it into something concrete like a number. And so there are 2 issues that we need to be concerned about when we talk about using tests to measure a construct. This is true for a lot of things, by the way. In psychology, we try and test a lot of abstract concepts using tests. So we have tests that'll assess, whether a person has depression symptoms, or a test to measure whether a person's introverted or extroverted, things like that. And so these are concerns for all of our psychological scales and tests. And then the other place where you see these a lot is in, every college class you take that has a test, right? We give you an exam, and what we're trying to do is take this abstract thing called your knowledge of the material in this class and convert it into some kind of number, something concrete. So these are issues that I know for me, I always worry about with regard to my own tests. So step 1 is reliability. We can define reliability as the consistency of a measure. There are lots of different ways that we can assess reliability, but the most common way is what we call test-retest reliability. And it's exactly what it sounds like. We administer the test to an individual, and then sometime later we test them again. And we look to see whether those 2 scores are the same. That's the consistency of the measure. IQ tests have really strong test-retest reliability. You can test a person when they're, I'd say probably the youngest that I would feel super confident is 8. I probably wouldn't take a test score from a person who is much younger than that and expect them to be consistent into adulthood, because there's a lot of variability on performance when they're little. But probably by the time you're about 8, until probably your late 70s, we would expect your intelligence scores to be roughly the same. That, if we test and retest you with lots of stuff in between, your score will probably not change much. It's a highly reliable measure. So what we're talking about there is that your score clusters. Let's imagine you're an archer instead of a person who's trying to test intelligence, and you're shooting at the target. The arrows are clustering close together. They're in the right, you're doing the same, whatever you're doing it the same way every time. But one of the things we're concerned about with intelligence testing is that we might be highly reliable, but that we're not really testing what we're claiming to test, that we're not validly testing the concept of intelligence. So validity gets at whether a test measures what it is intended to measure. Is it really measuring intelligence? We typically evaluate this as what we call constructive validity. Is it testing the construct that it's been designed to test, right? So validity would be, oh, look, see, I'm hitting the target once, and then all the rest of it's all over here because it's not a very reliable measure. But I did hit the target. What we're seeking is something that's valid and reliable. And we want to be hitting the target that is actually measuring intelligence, and we want to have the same score every time a person takes that test. So this is the challenge, right? And it's something that psychologists have been struggling with for the past, 100 years, 125 years probably by now. That we have good, reliable tests. You would probably perform the same every time you took it, and yet it may or may not actually be tapping into intelligence. And this is where there's a lot of debate, especially by lay people who don't understand testing, that intelligence tests aren't valid. We can't say that. We can't say that intelligence tests aren't valid. But we can say, what we can see is that they are reliable. They are definitely reliable. They might be valid. I'm not sure. They could be valid. So I'm going to go ahead and stop here. We're going to move into this concept of general intelligence versus specific intelligences. And this might help to delineate the validity issue. So I'll see you in the next video.